Hi, welcome back to Chemist Corner. I'm Jim McConnell, McConnell Labs, manufacturers of light elegance nail products. Today, in Chemist Corner number 8, we're talking about strength and durability and how does that relate to products that you put on your fingernails. So what we're going to talk about today when we talk about strength and durability is how much strength, how much force does it take to actually stretch something, and how do we measure that? What does it wind up meaning for you as far as durability, length of stay on the fingernails, and how long will it last? That's what we're talking about today. What we use in the back is typically what's called an Instron testing equipment. The Instron tensile elongation tester, what it does is you have a readout. The readout will measure either grams or pounds or ounces, depending upon how sensitive you want to make it. It has 2 clamps. One clamp goes up, the other clamp stays stationary down below, and it will clamp a specimen inside those 2 clamps and then pull on it. Pretty simple. So when we want to go ahead and do our test, we'll put our specimen in there, and the clamps will clamp it down. We'll push the up arrow. This clamp will raise up. The load cell that's here or here will measure out in there. Load cell actually just measures out the amount of force it takes, or the compression, or the weight. It's measuring that. It's kind of like a scale attached to a base unit. And then it'll stretch. And we'll measure how far it'll stretch, and we also measure how much force it takes to stretch it. Typically, when tensile strength and elongation are measured, you'll get the actual measurement of the force it takes at break. So what's the maximum amount of force it takes to stretch it until it finally breaks? So that's what we're testing here. The higher the tensile strength, usually the stronger the material. The more elongation it has, the less lifting you're going to see, because that elongation allows it to bend easily, and the more easily it'll bend, the less it's going to resist coming off of your fingernail. The other thing that has an effect on this is hardness. So we try and maximize the hardness to give us the scratch resistance we're looking for, but at the same time not make it so hard that it won't flex or bend or allow some elongation. So if we make it too hard, it's not going to stretch as far as we want it to. Therefore, it's not going to have the elongation. It will cause cracking and breaking. So that's what we're looking at. We're going to go ahead and take you back to the lab. And in the lab, we'll show you exactly how much force it takes to stretch this rubber band. And then we're also going to show you how much force it takes to stretch some of our gels that we make. So coming back to that, we'll come back here when we're done with that test, and we'll go over some of those results. Thank you. Okay, welcome back. So that was pretty interesting in the lab. We're really happy to show you what those tests look like in actuality. Ultimately, what that means is that the gels that we make here are actually a lot stronger than this rubber band. They don't stretch as much as the rubber band, and they're going to be a lot more durable than the rubber band. So we don't want to put a rubber band on your fingernails. One, that would be pretty ugly because it's not a very attractive color. But at the same time, we also make sure that it's going to be applicable for what the service is that you are looking for. If you want to hold together some paper, a rubber band is much better. But if you want to actually have something stay on your nails, a rubber band is not that great. So we want to make sure that we're using a gel, nice clear gel, beautiful gel, durable gel with a nice gloss, good durability, good hardness. So that's what we're looking for. If you have any questions, go ahead and post something in the message area down below, or you can give us a phone call. And this is Jim McConnell with McConnell Labs, manufacturers of light elegance, and this has been Chemist Corner. Thank you.